Welcome to another unit in this methodology toolbox. This time I want to talk about working and modeling networks, or rather preparing network data in a way that it can be analyzed analytically with some kind of given mathematical statistical measures. So when we have network data, we can first differentiate certain properties which our network has. And well, in this context, let me differentiate network into the nodes, so the different points in my network, and the edges, that's the lines connecting the different nodes. So if we first consider our nodes, we can have, for example, the nodes representing individuals, could be groups of individuals, could ever also be ideas, concepts. So the idea what our nodes are is very broad. So it's only important that you can in some way link these nodes to each other. So if it's different concepts, there needs to be some kind of interlinkage, like this concept led later on to a different concept that links these two concepts. So nodes can be almost everything. The important part is also what links these nodes. Well, edges can, as I said, be different links, but edges can also have some specific properties. The first difference could be, are the edges directed or undirected? What's the difference? Directed means you can go only in one direction across this edge. That's like a one-way street. Or in a different context, if we consider social media, if we have Instagram on the one hand, if I follow someone else, he not necessarily follows me back. So that's a one-way street. That's a directed network. Instagram is a directed network. Facebook, on the other hand, if I'm friends with someone else, he's automatically friends with me. So this works into both directions. That's an undirected network. If it goes both directions, two-way street, that's an undirected network. And we can also differentiate between weighted and unweighted edges. Because, well, if I'm linked to someone else, it could differ whether it's a very strong or relatively weak link. How well do I know someone? That's what the weights, for example, could express. How strongly do I follow the progress of someone else? On a social media context, how often do I like posts from someone else? How often do I comment on posts from someone else? However, the weights could also express the type of relationship. Am I just friends with him? Am I in a relationship with the other person? All these could be expressed by weights. So that would be weighted networks. Unweighted, well, it's basically just 0 or 1. 1 there is a link, 0 there isn't. Well, if I go with, I could have types of relationships. So I could have overlapping networks. If I have only a single layer, that's a simple single value network. If I have overlapping networks, so for example, who is friends with whom, who works together with whom, that's already two layers of a social network. That would be, if I want to express this in a single version, as a multi-value network. So once we have these informations, we can ask ourselves, how can I actually represent my network? How can I represent this mathematically so that later on I can actually apply my measures on this? I could focus on the edges. Then I can use the most common version to represent a network mathematically. That's the adjacency matrix. Here I have columns and rows, and I always go with, if there is a link from node I to node j, then the entry ij, so the element of the matrix at position ij, contains either the weight of this relationship, or a 1 if there is a relationship, or a 0 if there is none. That's a classical way. However, I could also note all the different edges which exist in my network. That's what I would do in an edge list. The edge list makes sense if I have very few links in my network. If I have more links, an adjacency matrix might make more sense. An adjacency matrix might also make more sense if I actually need to apply methods which assume I have matrix data available. However, if I have sparse data, an edge list might be a decent way of storing the links. Well, instead of the edges, I could also focus on the nodes. Classical alternative to the edge list would be a node list, meaning I have an overview of all the nodes and I can note who this node is actually linked to, who this is followed, who follows this node. And that's also something leading to a specific kind of node lists. That's a so-called precedence or successor lists. So if I have some kind of flow diagram, starting at the left with the initial steps, ending at the right with the final steps, I can always note for each of the steps, which are also nodes of a network, who are the preceding nodes, who are the succeeding nodes in this flowchart. That would be a precedence or successor list. Well, that's already everything I wanted to mention here regarding how can I prepare my network data to make it available for later analysis. So this concludes the session. I say goodbye and see you next time.